Welcome back, learners. As we have said, we're going to look at our first concept, whereby now that is going to be the components of an electrical circuit. So let's start. The components of an electrical circuit. So we are basically looking at the series circuit and the components that you find in an electrical circuit, in this case being a series circuit. Now, what is a series circuit? Now, that is one in which there is only, so that's a circuit where there is only one pathway for electric current to flow. So a series circuit is one in which there's only one pathway for the electric current to flow. So if current is flowing in one direction, not going anywhere all around the particular circuit, if it's going in one particular direction, then we can call that a series circuit. Now, the components are arranged one after another in a single pathway. So all the components that we find, or all the components that are in a circuit, if they are arranged one after the other, then we can call that particular circuit a series circuit. Why? Because the electric current will not be going all around the circuit in trying to go through those other components. If they are arranged in one after the other, they will just be moving in one direction, in one pathway, and hence we call that a series circuit. So when we connect these components, we say that they are connected in series. When they are connected one after the other and the current will be going through that same direction one after the other, we then say that those components are connected in series. So a series circuit with one pathway from the current, that now meaning that we are starting from the negative to the positive terminal of the battery without going anywhere else, in just one pathway from the negative terminal to the positive terminal of the battery. When looking at this particular diagram that we have here, when our current is moving from the negative to the positive terminal, it is going to be moving in one direction, going all around into back to the cell that we have, or back to the battery that we have, moving in one direction and not going anywhere else. In addition to that, the components that you find in an electric circuit are as follows. We have an ammeter. Now, that ammeter, that's a measuring device that is used to measure the electric current in a circuit. So in order for us to measure the current inside the circuit, we use this device called an ammeter. So the symbol for an ammeter in any of our electric circuits is going to be given by this particular symbol, whereby we have an A for ammeter inside that particular, or in between the wires in a particular circuit. So this ammeter is connected into the circuit in series. Why? Why are we saying that? Because it is going to be connected after any other component. Could be a resistor, it could be any other device. As long as this ammeter is connected after it, or even before it, then we're saying that it is connected in series. So the current that you're going to be measuring by this device, we know that it is measured in amperes, or with the symbol of A. A for amperes, and we know that that's the measuring unit for the current that we are talking about. In addition to that, we also have resistors. In this case, we're talking about the light bulbs. The light bulbs as a resistors that we find in an electric circuit. We know that resistors are a bit of both the insulator and a conductor. Why? Because they are conductors, because they do allow electric current to pass through, but they are a bit of insulators because they do not make it easy for that electric current to pass through. So they do allow it to pass through, but do not make it easy for it to pass through. So therefore, they are said to resist the movement of electrons. So these electrons are our electric charge. So they are resisting the movement of these electrons, hence the name resistor. They are resisting the movement of the electrons. So therefore, the resistors influence the electric current in a circuit. We know that the relationship between the resistor, or the resistance, and the current in a circuit is that once the circuit has a high resistance, that means the current in that particular circuit is going to be low. Why? Because if the resistance is very high, the resistance of the movement of that electric current is going to be high, meaning that the current that will be passing through that resistance is going to be small. So that means when the resistance of a circuit increases, the current is going to decrease. However, if the current of this circuit is increasing, that means the resistance of this circuit is going to decrease, or it has decreased. So those two components, or those two devices, or those two things, they will have that particular relationship, that when this increases, that is going to decrease. When resistance increases, the current is going to decrease. Now, this resistance that you're talking about, we said current is measured in amperes, or with the symbol, or with the unit A, to show that it's amperes. The resistance, it is measured in ohms with the symbol omega. It's written like this. So this symbolized by the Greek letter omega. So resistance is measured in ohms, whereas the current is measured in amperes. Remember, we are using an ammeter to measure our current passing through any electrical circuit. In addition to the resistors again, we said as we add more resistors, or as more resistors are added in series, the total resistance of a circuit increases. And remember, once the resistance of the circuit increases, the current is going to decrease, because the resistance and the current, they have that relationship that when one increases, the other one is to decrease. So, as the total resistance increases, the total, or the current strength, is going to decrease. So as we have said, when this increases, that needs to decrease. The strength of the current needs to decrease because of the relationship that they have. So in a series circuit, there's only one pathway for the electrons to move through the current. The current strength is the same everywhere in that pathway. So as we have our red dot moving in this one pathway, it has only just this pathway to move from one point to the next. And within that, we are saying that the current at any of these points, it is going to be the same. So if you take our ammeter and measure the current between these 2 points, and also measure it between these 2 points, measure it between these 2 points here, the current in any of these points that we have measured from will always be the same. Why? Because current only has that one pathway for it to travel through. So regardless of where we are measuring in an electric circuit, the current will always be the same. So what we have here is our simple series diagram, or a simple series electric circuit, whereby we have a light bulb, which is our resistor. So our light bulb, we're going to use it as our resistor, and then we have a battery. Remember that we have 2 cells. The one positive terminal and the negative terminal makes one cell, and the other negative terminal and the positive terminal, they also make another cell. Combined, they make a battery. So a battery is made up of 2 or more cells. And then we have our switch. Remember, when we open a switch, that means we are disconnecting the circuit. That means there's no current flow. However, if we are closing the switch, there's going to be a current flow. Hence, now the light bulb is going to light up when the switch is closed. So learners, before moving on to our next concept, quickly go for a short break, and I will see you just after the short break.